Hey guys, it's Miss Rainey. Today we are going to talk about chemical nomenclature and reactions. For the first part of our unit, we are going to be looking at nomenclature and naming compounds. So I hope you're excited as I am. Let's get started. Okay, so we're going to start with covalent compounds. Remember that covalent compounds are made up of two or more non-metals. So let me draw you a little periodic table over here. In case it's been a while and you forgot what a periodic table looks like, hold on. My baby periodic table. There we go. And the nonmetals are on the far right-hand side. So that's nitrogen or oxygen or fluorine or chlorine, things of that nature. Okay, here's our rules. First of all, we're going to name them with prefixes to indicate the number of each atom present. Our prefixes are, for one, mono, two is di, three is tri, four is tetra, 5 is penta, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. Those are our prefixes. The prefix mono will never be used with the first element, only with the second element. And we're going to change the ending of the second element to "ide." So let's practice that. I see here that there are two nitrogens. The prefix for two is di, so that would be dinitrogen. And then I also see that there are three oxygens. The prefix for three is tri, so that would be triox. And then not trioxygen, but we're going to change the ending of the second element to "ide, so trioxide. All put together, that is dinitrogen trioxide. All right, let's try another one. Now I've got one carbon. So I feel like if I've got one, I want to call it monocarbon. But that's a trick because the prefix mono never gets to be used for the first element. So instead it's just called carbon. For my second element, I am going to use my prefix. So for my second element, I see that there's only one oxygen, so I will use the prefix mono. Let me try that again. Try that. Try mono, and then oxide, and we're going to end it in ide. So that here we have carbon monoxide. And that's how we're going to name covalent compounds with two or more non-metals. Now we're going to go for ionic compounds. Remember that ionic compounds have a metal and a nonmetal? Metal and a nonmetal? Or a metal and a polyatomic ion. So these guys come from the opposite ends of the periodic table. So the first ion in an ionic compound is the cation. The cation is the positively charged ion. The positively charged ion is always written first. So for the cation, the first ion, we're going to write out the element name. So if it's Cu, that's copper. Mg is magnesium. Na is sodium. But we're also going to add Roman numerals if the element has a variable oxidation state. And we're going to assume for our purposes that every element has multiple possible charges. That means every cation gets a Roman numeral except, and here's our exceptions, group 1 and silver are both +1, group 2 and zinc are both +2, and aluminum is +3. These are the ones that don't require Roman numerals. Everything else does. Doesn't need Roman numerals. So if I were to have Mg, that's the word magnesium, and magnesium is in group 2, so it doesn't need a Roman numeral, so Mg plus 2 is just magnesium. If I were to have Cu, Cu is copper. Copper is in the transition section. It is not group 1, it's not group 2, it's not silver, zinc, aluminum. So copper does need the charge, and so then the Roman numeral for 2 is 2. Then we have copper again, but this time the charge is +1, so it would be copper 1. So Mg plus 2 is just magnesium, Cu plus 2 is copper 2, and Cu plus 1 is copper 1. The second ion in an ionic compound sometimes is a polyatomic ion. A polyatomic ion is a many atom ion. So it's an ion that acts like something that has a negative charge, but it has multiple atoms within it. So PO4 -3 has phosphorus and oxygen, or HCO3- has hydrogen, carbon, and oxygen. Within a series, all polyatomic ions will have the same charge. Let's see if I can get there. Within a series, I'll have the same charge, such as nitrate and nitrite are both -1, or sulfate and sulfite are both -2. So that'll help you when you're trying to memorize them and see them. All right, let's name that second ion in the ionic compound. So for the second ion in the ionic compound, it can be an element. If the anion, remember the anion is the negative ion, the cation is positive, we're going to write the name but change the ending to "ide." So if we had Mg, remember we just learned a minute ago that that was magnesium, and then Br2, my second element is Br2. So since this is just the element bromine, I'm going to write bromide. So that will be magnesium bromide. For Fe, a minute ago we learned that Fe was iron, but also that Fe is going to need a Roman numeral. So for the moment, I'm just going to put a space for the Roman numeral, finish naming it, and come back to that Roman numeral. So I have oxygen, so that's going to be oxide. And I don't have to name the prefixes like O3 is trioxide, it's just plain oxide, but I will need that Roman numeral. So I'm going to need to refer to my periodic table. Remember that oxygen has a -2 charge. Since there are 3 of them, that's a total of -6 for the oxygens. So the iron has to be equal and opposite to get this to be neutral, which means the iron is going to have to be +6. But since there are 2 of them, each individual iron has a charge of 3. My Roman numeral is 3, iron 3 oxide. If the anion is polyatomic, we're just going to get the name straight off that chart exactly as it is. I don't have to worry about Roman numerals or changing the ending. So Cu is copper. If we remember, copper is going to need a Roman numeral, so I'm just going to leave a space here for it and come back to it. Then I'm going to look at my polyatomic ion chart and see CO3 is carbonate. So now, looking at my polyatomic ion chart, I see that carbonate has a -2 charge. I need copper to be equal and opposite to make the compound neutral. So copper is going to be +2. Since there's only one copper, the Roman numeral is 2. That'll just be copper 2 carbonate. Here I've got NH4, which is a polyatomic off the chart. It's called ammonium. Since it's coming straight from the chart, I don't have to think of Roman numerals. I don't have to think of anything else. It's just ammonium. The C2O4 is also coming straight off the chart. That's oxalate. So this is called ammonium oxalate because that's all it is. I don't need a Roman numerals. I don't need to do anything else for it. Just ammonium oxalate. Remember, every single name has only 2 words. Only 2 words. So ammonium oxalate, copper carbonate, iron oxide, even carbon monoxide for my covalent compounds. Names will only have 2 words. So when you see something complicated with 4 different elements in it, we're still going to split it up into 2 words. All right, so the last type of substance we're going to learn how to name is acids. And so acids are special because they always start with hydrogen. Acids will always start with hydrogen. Make that H a prettier H. Let's try that again. Hydrogen. And so they look kind of like ionic compounds because hydrogen's on the left-hand side of the periodic table with nonmetals that are on the right. But they're actually hydrogens and nonmetals, so they're kind of like covalent, and they have their own special rules. So first of all, with all acids, no matter what type of acid it is, the name will always end with the word acid. It always stops with an acid, so we know it's an acid. Binary acids are a special acid, binary meaning 2 types of atoms. There's hydrogen and then one other thing. For binary acids, the name will start with the prefix hydro and end with the suffix ic, and in the middle there is a stem for what other element you have. So hydro, stem, ic, acid. For example, if we have HCl, we know this is binary because there's only 2 elements, hydrogen and chlorine. So it will start with hydro, and then we're going to get the stem from chlorine, and so the stem from chlorine is chlor, and then it's going to end with ic acid. So hydro, stem, ic acid. Our next one, we know this is binary because there's 2 elements, hydrogen and sulfur. So 2 types of things. So since it's binary, it starts with hydro. And then we look at the stem, sulfur. And for sulfur, the stem is sulfur, just sulfur, ic acid. So that's hydrosulfuric acid for the binary H2S. The other type of acid is ternary, and so ternary means 3. There are 3 types of atoms. There's hydrogen and oxygen and something else. So here we're made from and named similar to the polyatomic ions, but we change the ending of the polyatomic ions instead of getting them directly off the ion chart. So your 8 ions will turn into ic acids. So C2O4 is oxalate. We're going to take off the 8 and change it to ic acid. So OXAL, and instead of ATE, IC acid. So this is C2O4 and this is H2C2O4, telling me that we have an acid. If we have an ite ion, it's going to turn into an us acid. So SO3 is sulfite, and I see sulfite here in the acid, but it starts with hydrogen. So we're going to change the ending ite to us. So then SULF. And remember the stem for sulfur is sulfur, and then us acid. So H2SO3 is sulfurous acid. And then the prefixes, if there are any prefixes, those just stay the same. That doesn't change anything. So MnO4, we have MnO4, that's permanganate. I'm going to leave the beginning part alone. I'm only just changing the ending, 8 to ic. So this is permanganic acid instead of permanganate acid. And our last one, ClO, I see ClO, that's hypochlorite. I only need the ite part of it to change to us, so hypochlorous acid. All right, so there are my acids. Now you get to practice on your own. You're going to name these compounds below using the rules that we just went over on your own. Pause your video, try the work, and then unpause and check your work with me. Don't check your work with me until you have work to check. So pause now. So hopefully you paused, you took a break, and now you've got some answers for these. Remember, when you're naming compounds, you get only 2 words per compound. And also when you're naming compounds, there's different rules. So you have to identify if it is covalent, ionic, or an acid, because there's different naming rules depending on which one it is. So we are looking at NaNO3. When I see NaNO3, I'm identifying this one as ionic because I see a metal and a polyatomic ion telling me we are ionic. We get only two words, so I'm going to split it in half. Na is sodium. Just didn't name that right. Let's try again. Na is sodium. And then sodium, since it's in group 1, does not get a Roman numeral, so we just have the word sodium. NO3 is nitrate. That's just sodium nitrate. Our next one, we have a metal and a nonmetal, so this is also ionic. Cu is copper. Copper does need a Roman numeral, so I'm going to just put a space in the middle and come back to it. Cl is chlorine, so we're going to change it to chloride. And then we have to come back for that Roman numeral. So for the Roman numerals, we have to check the chlorine is a charge of -1, and there are 2 of them. Since there are 2 -1 charges for chlorine, in order to balance it equal and opposite, copper has to be +2. So this is copper 2 chloride. Then we have HBr. Ooh, that starts with H. That means it's an acid. It's also binary acid. So it's going to be hydro, and then the stem for Br is brome, bromine, it's going to be brome, and then ic, acid. That's how we'll name binary acids, hydrobromic acid. All right, next we have, I just see NO2, and those are all nonmetals. That means this one is covalent. Covalent needs the prefixes unless the first element only has 1, which it does here. This is just plain nitrogen. The prefix for 2 is di, so dioxide. Be aware that this is not nitrite because there is no charge in this top corner. It would need a charge in the top corner in order for it to be nitrite. With no charge, it's just nitrogen dioxide. All right, I'm going to do another one. I see also, again, all nonmetals, so we have a covalent compound. There are 2 sulfurs, so disulfur. There are 10 fluorines, so decafluoride. Remember, we're always changing the ending to "ide." All right, and my next one, let me see. Ooh, I see it starts with H. That means it's an acid, so it's going to end with the word acid. All acids end with the word acid. But this one's a ternary acid because there's 3 elements total, nitrogen and oxygen. So NO2 from your polyatomic ion chart is nitrite. But instead of "ite", I'm going to change the ending to "us", so nitrous acid. All right, there's our first 5. Let's keep going. I see another acid because I see it starts with H. So since I have an acid, it's going to end with the word acid. Now I'm going to look at the other part of it. So I see SCN. This is thiocyanate from the polyatomic ion chart. So this is going to be thiocyanic acid. Thiocyanic acid. All right, my next one, oh, also an acid because it starts with H. So I'm going to end with the word acid. I'm looking at SO4. SO4 off of my chart is sulfate. So sulfuric, because the prefix for sulfur is sulfur. Sorry guys, sulfuric acid. So H2SO4 is sulfuric acid. If you just put sulfic, that'll be fine. All right, next I've got Pb and MnO4. That's a metal and a polyatomic ion, telling me we have an ionic compound here. Pb is lead. Lead does need a Roman numeral, so I'm just going to put a spot and then come back to it. MnO4 is permanganate. Space there. So now when I look at permanganate on the ion chart, I see that permanganate is a -1. I also see that there are 4 permanganates, which means that lead has to be equal and opposite. So there's -4 for the permanganates. There has to be +4 for the lead. There's my lead. Lead 4 permanganate. All right, going again. I see 3 elements here, but I'm going to have to split it in 2. So S2O3 is on my ion chart. That is something that I don't know. S2O3. So S2O3 is thiosulfate. So Ca is calcium, calcium, thiosulfate. That's just calcium thiosulfate. Calcium does not need a Roman numeral, so then we're just good there. All right, I'm getting close to the end and running out of space. This one is going to be also an ionic compound because I see a metal and a polyatomic ion. Na is sodium. C2O4 is oxalate. It does not need a Roman numeral, so this is just sodium oxalate. And last but not least, I see K and H and CO3. There's a lot of elements here, but if you check your polyatomic ion list, HCO3 is all together as one. K is potassium. It does not need a Roman numeral. HCO3 is either called bicarbonate or it's called hydrogen carbonate. Either way, so this can be potassium bicarbonate or potassium hydrogen carbonate. All right, guys, those were naming acids and ionic compounds and covalent compounds. And I hope you got something good out of that, and I will see you next time.